Let us now have a look at some important points we need to remember while dealing with indices. A raised to the power m gives a raised to the power n, which implies that m is equal to n. For a raised to the power m equaling to a b raised to the power m, where m is not equal to 0, implies that either a is equal to b if m is odd, or a is equal to plus minus b if m is even. It is time for some concept application. Let us now consider the following question. Which is greater among the two, cube root of 9 or the fourth root of 20? Now cube root of 9 is equal to 9 raised to the power 1 by 3, and the fourth root of 20 is equal to 20 raised to the power 1 by 4. The LCM of the denominators 3 and 4 of the fraction is 12. Therefore, 9 raised to the power 1 by 3 can be written as 9 raised to the power 4 by 12, which gives the 12th root of 9 raised to the power 4, which is equal to the 12th root of 6561. And so, 20 raised to the power 1 by 4 can be written as 20 raised to the power 3 by 12, which gives the 12th root of 20 raised to the power 3, which equals to the 12th root of 8000. Therefore, the 12th root of 6561 is less than the 12th root of 8000. Well, throughout the past so many years, we have seen in the CAT exam, there have been questions related to finding out the last digit of a to the power x. We will now see the various methods of doing so. Let us have a look at the last digit of 2 raised to the power x. We first now draw a circle. Then we put 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3 and 2 raised to the power 4 on the circle. We will go on the anti-clockwise direction starting from 2 raised to the power 1. The last digit of 2 raised to the power 1 is 2. The last digit of 2 raised to the power 2 is 4. The last digit of 2 raised to the power 3 is 8. And the last digit of 2 raised to the power 4 is 6. Now draw two lines joining diagonally opposite numbers and extend them. We then draw two concentric circles. The point where the line through 2 raised to the power 1 cuts the two circles are marked as 2 raised to the power 5 and 2 raised to the power 9 respectively. We do it simply by adding 4 to the powers. Similarly, the points where the line through 2 raised to the power 2 cuts the two circles are marked as 2 raised to the power 6 and 2 raised to the power 10 respectively. Similarly, the points where the line through 2 raised to the power 3 cuts the two circles are marked as 2 raised to the power 7 and 2 raised to the power 11 respectively. Also, the points where the line through 2 raised to the power 4 cuts the two circles are marked as 2 raised to the power 8 and 2 raised to the power 12 respectively. The powers on a line will give the same last digit lying on the line. For example, 2 raised to the power 1 and 2 raised to the power 9 will have the same last digit 2 as the line which passes through those powers passes again through 2 as the last digit. For the sake of generalization, we take k equaling to 1, 2, 3 and so on so forth. We can write the general powers of 2 in terms of k, whose last digits will be the one as shown in the diagram. In this way, we can easily calculate the last digits of whatever powers of 2. Let us have a look at the last digit of 3 raised to the power x. We first draw a circle. Then we put 3 raised to the power 1, 3 raised to the power 2, 3 raised to the power 3, 3 raised to the power 4 on the circle. We will go on the anti-clockwise direction starting from 3 raised to the power 1. The last digit of 3 raised to the power 1 is 3, 3 raised to the power 2 is 9, 3 raised to the power 3 is 7, and 3 raised to the power 4 is 1. Now we draw two lines joining diagonally opposite numbers and extend them. We then draw two concentric circles. The points where the line through 3 raised to the power 1 cuts the two circles are marked as 3 raised to the power 5 and 3 raised to the power 9 respectively. We do it simply by adding 4 to the powers. Similarly, the points where the line through 3 raised to the power 2 cuts the two circles are marked as 3 raised to the power 6 and 3 raised to the power 10 respectively. Also, the points where the line through 3 raised to the power 3 cuts the two circles are again marked as 3 raised to the power 7 and 3 raised to the power 11. The points where the line through 3 raised to the power 4 cuts the two circles are marked as 3 raised to the power 8 and 3 raised to the power 12. The powers on a line will give the same last digit lying on the line. For example, 3 raised to the power 1 and 3 raised to the power 9 will have the same last digit 3, as the line which passes through those powers also passes to 3 as the last digit. Now for the sake of generalization, we take k equaling to 1, 2, 3 and so on so forth. Also we can write the general powers of 3 in terms of k whose last digits will be the 1 as shown in the diagram. In this way, we can easily calculate the last digits of whatever powers of 3. Let us have a look at the last digit of 4 raised to the power x. Now as we did for the previous cases, we again draw a circle. Then we put 4 raised to the power 1, 4 raised to the power 2 on the circle. We will then take the anti-clockwise direction starting from 4 raised to the power 1. The last digit of 4 raised to the power 1 is 4 and the last digit of 4 raised to the power 2 is 6. Now we draw a line joining the 2 points and extend them. Again, we proceed in the similar way like we did in the previous examples. For the sake of generalization, we take k equals to 1, 2, 3 and so on so forth. We can write the general powers of 4 in terms of k whose last digits will be the 1 as shown in the diagram. In this way, we can easily calculate the last digits of whatever powers of 4. Now let us have a look at the last digits of 7 raised to the power x. In the same way, we again draw a circle. Then we put 7 raised to the power 1, 7 raised to the power 2, 7 raised to the power 3 and 7 raised to the power 4 on the circle. We go the anti-clockwise direction starting from 7 raised to the power 1. Now the last digit of 7 raised to the power 1 is 7. The last digit of 7 raised to the power 2 is 9. The last digit of 7 raised to the power 3 is 3. And the last digit of 7 raised to the power 4 is 1. Now we draw two lines joining diagonally opposite numbers and extend them. Then we proceed again in the similar way we did in the previous examples. For the sake of generalization, we take k equaling to 1, 2, 3 and so forth so on. We can also write the general powers of 7 in terms of k whose last digits will be the one as shown in the diagram. In this way, we can easily calculate the last digits of whatever powers of 7.